Hey, you. Yeah, you. Take out yesterday's notes.
State the measure of the given angle. And draw this picture. So draw the X and Y axis, or something like this. So here the goal is for you to tell me the measure of the angle, the one that looks like a spiral. Is the angle going to be positive or is it going to be negative? Well, is it moving clockwise or counterclockwise? This is moving counterclockwise, so we know that it's going to be positive. I'm going to trace the spiral with a different color, and we'll keep track of how much we have as we go along. So how much is this so far? So far, that's 360. Let me throw in an additional 90. Now, if this piece here is 42, that means that this little snippet is 48 because this whole section is 90. So I need 48 more on top of all of that. And so now we add these up. So I have 498 degrees. And we did say that it's positive because it moved in a counterclockwise direction. Let's do one more. Something like that. And then draw that. But I do know that it moves clockwise. So I'm prepared to give them an answer that's negative. Now let's tally this up like we did this one there. So far that's 360. And then I continue. That's another 360. And let's keep going here. How about that's another 360. And then again, if this dotted piece is 62, that means that this little chunk there has to be 28 because they add up to 90. So throw 28 more in there. It is 1108 degrees, but what's missing should be negative because you moved in a clockwise direction. In which quadrant does the given angle terminate? Question mark. So let's do two examples here. Example A, example B. So how about something like 500 degrees? I want to know in which quadrant does this finish? If I were to draw this, in which quadrant would it stop? Well, let's do that. Let's draw it. And let's see where it finishes. It is positive, so I'm going to move counterclockwise. Now, so far, that's 360. But to reach 500 from 360 to 500, I need 140 more. So 140 more from here would be roughly there. And so that's the angle, but it wants to know in the quadrant in which it terminates. Well, this angle stopped in quadrant number 2, so that's the answer. So this ends in quadrant 2. Did I need a picture? No, but it helped. How about negative 12 pi over 5? That's in radians. So revisit yesterday's material. To deal with radians, maybe we can turn it into degrees. So let's do that first. So let's take negative 12 pi over 5, and we multiply by 180 over pi. And then go to your Casios. This should be negative 432 degrees. Now the graph of that, well, it's negative, so we move clockwise. 432. Well, so far, that's 360. Now from 360 to 432, how many more degrees is that? About 72, right? About 72 more. So something like here. That's where it stops. That's where it terminates. And what quadrant is this? That's quadrant number 4. All right, so one more quick concept. Provide one positive and one negative coterminal angle. So example A and example B. Now, what exactly is a coterminal angle? Time out. Coterminal angles. Co means together. Terminal means end. So these are angles that end together. Watch. 7 degrees. A 7-degree angle is something like this. Yes. Now what about 367? Well, 367 is first of all a full spin, which is 360. But to reach 367, I need a little bit more. So that angle ends up looking something like that. What about this one? Negative 353. Well, since it's negative, I'm prepared to move in this direction. But 353 is almost 360. So it's almost a complete spin. Almost a complete spin, but not quite so. Now, if I take a step back, if you look at all the angles, but what do you notice? They all end up pointing in the same direction. This one, and that one. That's what it means to be coterminal. Angles that they may have a different number, but what do they all do? They all point in the same direction. Now, is there a fast way of coming up with coterminal angles? Yes. The shortcut is basically add or subtract by 360 as many times as you want. Watch. Take 7. What's 7 plus 360? Boom, 367. What about minus? What's 7 minus 360? There it is, negative 353. So again, if I give you something and you want to find coterminal to that something, you can add or subtract by how much? 360. What about the other language? In radians, it would be add or subtract by 2 pi. So that's the really fast way of finding angles that are coterminal. Time in. So what about something like 637 degrees? I know how to make a picture of this, but I don't want that. I just want you to tell me 2 other angles, one that's positive and one that's negative, that if I made pictures of all of the angles, they would point in the same direction. And as was just discussed, the fast way to do that is just add or subtract 360 as many times as you want. So for instance, let's take 637. So take 637 and to it, why don't you add 360? And that says 997. So that's one of the answers. So now go back to 637 and this time subtract 360, but if you notice, it's still positive. So what should I do? Subtract 360 again. And that says negative 83. So done. Last one, negative 17 pi over 3. So it's the same trick, but this time we are in radians. Could I turn this into degrees? Sure, but then your answers would have to be turned back into radians. For radians, you could add or subtract 2 pi, because 2 pi is the same as 360. So let's subtract 2 pi, and that's negative 23 pi over 3. That takes care of my negative answer. Now for the positive answer, and this time let's add 2 pi. Notice it's still negative. So add 2 pi yet again. It's still negative. So add 2 pi yet again. And finally it says 1/3 pi. And again, there are many different answers, but these here are some of the acceptable ones. So now go off and try exit ticket number 12. and I'll talk to you guys tomorrow.